Okay, so let's start. Thanks for everyone who attended the webinar. My name is Daniel. I'm the Technical Customer Success Manager here at WinDriver by Django. This is the third webinar. We'll talk about the previous webinar soon from a series of webinars. This one will be dedicated for debugging and troubleshooting drivers. I am providing the support among other services for WinDriver, and this webinar was assembled with our R&D team in order to share the knowledge and experience gained through the years for how to debug drivers. It can be fairly complex process with a lot of moving parts. And here we will talk about how can we find the root cause of the issues as soon as possible. If you have any question during the webinar, feel free to write it on chat, to write to me, and I will answer by the end of the webinar. You have my email over here and our sales team email. You can contact us at any time regarding questions or feedbacks. So as I said, this is the third webinar out of 4 from this series. The first one introduced the main features of version 16.2, WinDriver version 16.2. We released it, if I remember correctly, 2 months ago, and it includes 2 main features. One of them is the predefined action flow, predefined actions, where you can predefine a flow sequence of actions to be performed on your device with access registers, and then running them one after another. I really recommend trying it. The second webinar, the second feature is for Windows. If you develop driver on Windows, you've probably encountered the digital signature enforcement, where you generate INF with WinDriver, and then you need to restart the computer and disable the digital signature enforcement each time, which can be very frustrating, especially during testings, where crashes and hangs can occur. So we released a solution for this hassle, where you simply install a self-test certificate with checking a box and a click, and then you won't need to restart the computer and disable the digital signature enforcement in order to install INFs generated by the wizard. All of this is shown and demonstrated on this webinar, the main features of version 16.2.0. The last webinar was approximately 1 month ago, and it was about the PCI diagnostic tool of WinDriver on the util folder, and especially focusing on the interrupt handler. We talked about we will talk about this utility in this webinar as well as a troubleshooting tool, but we show the interrupt handler and how it works, what is the flow, and how can you utilize it. And you don't have to generate anything. You can access your device and raise interrupts and send messages without generating even a project. So this webinar and the 16.2.0 main features webinar are on YouTube and on our website. We have a media section on WinDriver's website. I welcome you to go there and check out the content as well as the blog posts. We recently uploaded several blog posts, insightful content, and not just marketing stuff. Our next webinar on the 22nd of May will be about DMA. Now, DMA is a wide subject. In this webinar, we will talk about it's 101. It's the fundamentals. We will talk about different types of DMA, pooling and interrupt, and we will talk about scatter, gather, and contiguous. We will talk about the flow, the sequence, and our samples, the WinDriver DMA samples. Hopefully we will be able to demonstrate the DMA as well, although we know the hard work is not performing it, but to program it and make sure everything works. So if you're interested in DMA, especially if you're interested in performing DMA using WinDriver, I recommend signing up to this webinar. The link can be found on our website. Another thing I recommend you to take a look at, another media, is the predefined actions live demo from the Embedded World exhibition. This is also on the media section on our website. Shlomi, our account manager, demonstrated a live predefined action for changing lights, LED lights on a PCI card by accessing the device. And he showed how by a few simple clicks and definitions, you can perform live operations on your device through the wizard. So this is an insightful video, 8 minutes. It's worth it, especially if you're not familiar with this feature. And the last thing I want to tell you about is the WinDriver quick tutorials. So these videos, we call it WinDriver quick because we want them to be as short as possible and straightforward. So we have 2 already. I recommend checking them out. We will expand them. Our goal is to create a WinDriver Academy where we demonstrate really straightforward and simple, in a simple way, how to utilize WinDriver, how to use its utilities. So you will see more videos like this popping up. WinDriver Quick, you can find it on our website. So let's get to the business. What are we going to discuss today? So we will start with the methodology of how are we even approaching troubleshooting drivers, especially when we know there are a lot of moving parts from the hardware, the firmware, the kernel, the operating system, and the driver itself. We can talk about development, we can talk about distribution. So there are a lot of moving parts when we're talking about developing drivers. We will discuss the methodology. We will then see the tools we recommend to be familiar with when developing drivers, and especially troubleshooting them, both Windows, Linux, and WinDriver troubleshooting tools. We will overview the WinDriver mechanism and how can we troubleshoot basic WinDriver boot issues, setup issues, and all along the way we will see case studies. We will see. I will talk about the methodology, and then I will give an example of how of a case we had and how we utilized the tools and methodology in order to resolve the issue. So this slide main purpose is to show how many things can go wrong when developing a driver, and this is only when installing and utilizing WinDriver. We are not talking yet about other components like hardware issue or operating system issues. So maybe the first tip I can give when talking about WinDriver installation issues is follow the documentation. We have a very elaborate documentation. There are settings that should be prepared, and there are dependencies that should be installed, and everything is written down on the manual. So the best thing to do when installing WinDriver, or if you encounter issues, just follow the manual, and then most of the issues will be resolved just by following the steps. We know that some clients download the wrong architecture, so they have the wrong installation file. Some have previous WinDriver versions installed on the computer, which can cause kernel module issues because there is an already WinDriver kernel module that is being used by the operating system. So we also have a guide for how to upgrade your WinDriver installation and your WinDriver project driver. So everything is in the documentation. The first tip is go there, and you will find a lot of insightful information. So when we're talking about the driver wizard operation, if we encounter any issues, then it can be pretty or more easy to troubleshoot because we have our utility, our WD debug. We will elaborate it soon. When we generate a project, let's say in C, it's not on Python, but when we need to use an IDE, we need to make sure that the IDE has everything it needs in order to compile or interpret the code. So we saw that there are missing dependencies or settings that are not set correctly, or missing packages on the IDE. So when talking about compilation issues, or if we're talking about Linux, so the GCC is not updated, or libqt. So again, when talking about compilation, we need to make sure that our IDE is compatible and set according to the guide, so the compilation will go through smoothly. However, if you find issues with the makefile or with anything else, you can raise them to us and we will have a look. The user application part is maybe the most complex part because a lot of things, this is where the code runs, and maybe you added a code and then you ran the application and you got a crash or a hang, or you see that you are not getting the desired what you expected from the driver itself. So the user application part is the most interesting one, but also the one that we may see more errors. Beside code error aside, we can see invalid handle, which pops up in case the kernel module is not installed, crash or hangs that usually occur when the program writes to an invalid memory section. DMA limitations, we see that soon from the operating system or the BIOS. Interrupt handling issues, we will talk about the two. And hardware compatibility, this is another tip that I can give, is that you must be familiar with your hardware, especially if you're working with FPGA. This is a game changer. If you're familiar with your device, you will have a much easier life planning and configuring and getting what you want from the device. You have the access page on your specifications of your device, and it's critical to be familiarized with it or be in contact with the hardware developer that synthesized the FPGA, so you will be able to write an effective driver. The distribution part is also, we try to make it as easy as possible. You have the Redist folder on your project, but things can go wrong there. The renamed app issues, which we will upload a video of how to resolve it next week, I hope, or OS compatibility, etc. We have our documentation, and we have a whole section for distribution. If you're distributing your driver, I recommend checking it out. So this is the methodology slide, okay, section. I think maybe the most important word or phrase on our methodology is versioning. So we know that when we release WinDriver, it has been tested on several kernel versions and the operating system, Windows, Linux, now ARM. We have the XDMA samples tested on specific devices, and we know that things are working. However, issues can occur on different levels. The hardware can have issues, maybe physical issues like a burned connector or dirty socket, and the connection with the hardware wouldn't be good. The card itself, if it's the firmware, the configuration space maybe is not set up right. There can be compatibility issues with the kernel version or this specific kernel version. Operating system, if you're distributing for more than one operating system, things can work on Windows but not on Linux. The WinDriver version, and you get the point. Things are changing. There are a lot of steps along the way. The good news is it helps to break down the process and find where the root cause is. So what we recommend to do is versioning, is to check things on different kernel versions, operating system, WinDriver versions, and find something that works. And when things break, compare them. And this is the second part of the methodology. It's the diff and regress. So diff is, I believe you're familiarized with it. We recommend working with Notepad++ on Windows. And if you're on Linux, we recommend using the VS Code or vimdiff, which is a command in Vim editor. So once we have the logs, this is the next part of the slide of the presentation. Once we have the relevant logs, we can read the log. Maybe it's self-explanatory. And if not, we can compare between the working version and the non-working version. And this way, we start to eliminate the root cause and the things that cause the error. So versioning, diff and regress, and elimination, and I will demonstrate shortly how it is done using a case study. This is just a straightforward scheme to illustrate what I just said in the previous slide. Whether if it works or it doesn't work, log everything, and diff and regress in case of an error. In any case, we recommend to be familiarized with the tools and logs. Log things even if things are working properly. Read the logs, see what it logs. Be familiarized with the technical language of each tool. It will help you to troubleshoot better if things go south. So the first tool I will talk about is the WinDriver WD debug. This is in-house a WinDriver tool. You may be familiar with it. It basically debug the kernel operation of your driver. You can see here the commands, okay, that are being monitored. You have, for the high-level API, you can click on the function and you will get to the manual, the relevant section on the manual. The successful operations are marked with green, and the failed ones or errors are marked with red. So it is easier to troubleshoot. It got a facelift in version 16.1, and it's much more user-friendly. And we recommend running it regardless of if there are issues or not, because again, you can see a lot of important details. on the operation. You can see the cards, how many cards are scanned. You can see the addresses. You can see the domain bus slot and function, the VTPID. You can see a lot of things here. Very insightful information. Now, this is the debug options window. You can decide which sections you want to debug. I believe that you should check all the boxes here, but two main things I want you to pay attention here. First one is that you can send the debug messages to the operating system kernel debugger. On Windows, it's WinDBG, and on Linux, it's the dmessage log. So you can have a unified log of your kernel local operating system kernel debugger with WinDriver logs. And this is in addition, it's not instead of this log. And the driver name is important as well. The driver name should be the kernel module name of your driver. So if you are working with WinDriver or you have a kernel module that relies on WinDriver, an INF that relies on WinDriver kernel module, you can leave it like that, because then it logs all the kernel operations from this kernel module. However, if you renamed your driver, you're on a distributed computer, or testing it on a redistribution package, you should change the driver name to monitor your kernel module, your project's kernel module. This is how the log looks like. At the top, you can find the particular computer information, the WinDriver version. You can find the module it is logging, the operating system name, OS release, kernel version, and as I said, do PCI scan, low-level function. We can see errors, okay, that are errors that are written pretty clearly, okay? Error on unknown PCI header type, self-explanatory. We can see bars, addresses, physical. So it's a great log. Again, I recommend you to run the PCI diag or your driver and check it out and see what it writes. You can get a lot out of it when during development. Let's talk about Linux troubleshooting tools. So maybe the first one and most essential one on Linux is the dmessage. So dmessage is the command on Linux that displays the kernel messages, providing a record of the system's activities and events. It's valuable for troubleshooting because it offers insights into hardware and software interactions, error, and device status. You can identify issues, track down causes of problems, and make informed decisions to resolve them effectively. We are not asking it from anyone who reaches out who uses Linux, but it is very common. If someone reaches out with the Linux issue, we will probably, if it's not related to compilation and build, but to runtime, we will probably ask for the dmessage, because it reveals a lot. On the boot, it reveals a lot of things that happens in the kernel that are not related to WinDriver and debugged in the debugger, in the WinDriver debugging debugger log. The next command I will talk about is the LSPCI or LSUSB. The V stands for verbose. You can verbose it. One V is verbose, two V is very verbose. There are three Vs where you can get a description. So these commands are list information about devices connected to the PCI and USB buses, respectively. They are essential for troubleshooting as they help users to identify hardware components, their drivers, and their current status. You can quickly gather details about connected devices, aiding in diagnostic compatibility issues, driver problems, and hardware configurations. Why is this important? sometimes the driver wizard of WinDriver does not identify a device, and you cannot find it on the list, or the PCI diag, or you're running a driver and you are not able, to access it. LSPCI or LSUSB will list all the devices that the operating system or Linux recognize. So if the device does not appear on this list, that means that WinDriver or your driver will not see it. It also indicates an issue that lies between the connection, in the connection between the hardware and the kernel. So it narrows down the possibilities. And if your device is not on this list, no driver will be able to work with it. Another tool we recommend working with, and this is general not only for troubleshooting, but VS Code is a great IDE solution for Linux. It's friendly. It's more friendly than other interfaces. It supports various programming languages and extensions. You can have the integrated debugging, version control, intelligent code suggestions, and the diff. As I said earlier, the best practice we encourage to work with on Linux is Makefiles. Makefiles with VS Code is the perfect solution for building on Linux. If you want to learn more about it, write to me or see our documentation. CMake list on VS Code is a great solution for building on Linux. Vimdiff, as I said, is a text editor, but you can also write code there and perform diff between versions of logs. Let's talk about Windows. So the equivalent of the dmessage, dmessage is the setup API devlog. Okay, it is generated by Windows during the installation or configuration of hardware devices and drivers. It records detailed information about device and drivers installations, errors, and other related activities. You can track down failures, identifying driver conflicts, and understanding the sequence of events during device setup. This is a less common log we work with, but it is the most essential kernel debugger of Windows. So if you're not familiar with it, I'm sorry. What I talked about is the WinDBG. I'm sorry. Let's talk about the setup API devlog. My apologies. I confused. The setup API devlog monitoring the INF operations. We work with it a lot, okay? And it is very convenient because the way it's built and because the text. So let's see how it looks. You can find all the setup API devlogs on C Windows INF. Okay, this is the path, and the logs look like that. This is a WinDriver installation, INF installation log. For errors, you can see 3 exclamation marks, and 1 will indicate a warning, not an error, but it is very easy to navigate in it, and it provides a lot of insightful information. If you ever reached us on installation issues of WinDriver or your driver, we'll probably ask you for the setup API devlog. So go find it. It's a text file, and you can go through it and see if the INF installation was successful. The INF is critical. We will talk later about why. The PNP-util enum devices is the equivalent of the LSPCI and LSUSB. You can see a list of your devices. Again, if your device is not on this list or on the device manager, it is probably not recognized by your operating system, and they won't be able to access it. You can see the information it has, the class name, the GUID, GUID, the manufacturer name, the driver name, okay, the INF. You run it on PowerShell. If you're not familiar with it, go take a look. It's an important tool for troubleshooting drivers and hardware on Windows. The WinDBG is the equivalent of the dmessage. And here, okay, it's a powerful debugger provided by Microsoft for analyzing and debugging Windows applications, driver, and operating system itself. It helps developers identify and resolve software issues, crashes, and performance problems. WinDBG allows users to analyze crash dumps, memory dumps, and live debugging sessions, aiding in pinpointing the root causes of software crashes and behavior anomalies. So as you can see, it's more sophisticated than just logging from the dmessage. You can run flow, run the debugging, stop it. You can see crash dumps, which is very useful if you're getting BSODs from your driver. You can monitor the whole kernel operation right from here. It is more sophisticated than the one Linux provides. If you're not familiar with it, check it out. Write WinDBG on Windows search bar, and you will get there. Event Viewer is a monitoring system for processes. Okay, it provides centralized location for viewing and managing various systems, security, applications, event logs. You can see system activities, troubleshoot errors, and track changes on the system. So Event Viewer, it's less common for our usage, but a great tool as well. This and the Process Monitor and the Process Explorer that captures and displays real-time information about system and applications activity, including system registry and process thread activity. It used for diagnosing issues related to processes. So these two are also important to be familiarized with. We're not working with them daily, but know that they are there. Okay, there are tools that Windows provide for you to monitor the processes and kernel operations. So let's talk about diff and regress and everything we just talked about. How does it work? Or how do we translate it for steps, for actions? So in this case study, we had a client that his project or his driver ran on both Linux and Windows, okay? And the Windows device and driver runs with no issues, okay? So if we break down the development steps or the whole process steps, we have the device, we have the firmware. On Windows, it works well, the operating system is good, the device opens, and it performs the operations he requests. On Linux, however, things are not working properly. The device is not opening, and therefore no operation can be done. We asked for the dmessage log from Linux, and we saw there that this is from Linux kernel debugger, yeah, not from the WD debug, that this process can change power state from D3 cold to D0, config space inaccessible. So it raised the red flag, but it is not self-explanatory. We cannot blame nothing currently for the driver not to work, especially when it is working on Windows. So we know that the device is okay, the firmware is okay. This was our assumption. We thought it is maybe an incompatibility with the kernel version or operating system. And then we said, let's take the logs from Linux and Windows, and this is the WD debug log. Just a second. And we see, and we ask the client to run his driver on both operating system, log them, and send them to us. And this is how the diff looks like. Okay, so first we see errors here. We could not get the PCI header type. the host, the operating system, could not get the header type from the device. And we also saw that the operating system or the computer could not map the memory to kernel. Okay, we couldn't lock the card, whereas in Windows we saw that there was an issue as well for transcending the bus addresses on the card. We know that we're supposed to get the header type from the configuration space, which linked us with the config space error log from the dmessage. And we realized that the header types were unknown. Therefore, Linux and Windows could not access the configuration space. Okay, so the issue was on the configuration space. It was on the firmware. It was misconfigured. We asked the developer to go back to the planning board and reconfigure the configuration space so it will be accessible to the operating system. Now, the important thing I want to emphasize here is the fact that it worked on Windows. We had an issue on Windows, okay? We saw that there was a failure. It's critical. It's not something that we can just ignore. We assume that it worked on Windows due to a fallback. However, we know that Microsoft's love updating the kernel and updating versions, and sometimes things break. And these things are usually the first to break. The fallback maybe worked on the development computer, on the laboratory, in this specific Windows version. However, if he would distribute his driver or update the Windows version, it would probably break at some point, okay? This fallback would not last for too long. So we identified an error on Windows as well, only by looking at the logs, thanks to the issue on Linux. So after fixing the configuration space, the issue was resolved. Okay, so this was just an overview, a case study overviewing the methodology. In this case, working with different versioning between different operating systems. This is another slide, pretty straightforward, that emphasizes that it's not just about troubleshooting your computer or your kernel. It can go a long way to the hardware. We have the interrupts, which is a physical component, the memory ranges, the bit stream, the header types, everything is located, let's say, or sits in the device, in the hardware. We have the kernel mode, kernel vision compatibility, kernel debugging, kernel logs, and we have the user mode, okay, which we developed on. And something in this communication cannot work, and then we need to realize why. Let's say the example I will show soon is for raising interrupts. So it's a physical thing that happens in the device, and we expect to see it on the user mode, but something on the way will not work, and we'll see now what. So in this case, the developer used an FPGA with several interrupt sources. Okay, now if we look at this scheme, the developer expects to raise an interrupt in the device, okay, to the interrupt handler to listen to the interrupts, and then to see the logs. Okay, the driver should listen to interrupts and then print out in the log that the interrupt was raised. And the interrupt is just a part of it, yeah? You want maybe the transfer commands to be sent as well once the interrupt was raised. So this is the flow. We have the device, we have the wizard, and we have the driver, and each one. Now we need to understand why the issue was no interrupts were logged, even though they were raised in the card. Okay, so we asked for the WD debug log which is the WinDriver's home debugger. And we saw this error in transfer command. The memory address was out of range, and we see which transfer command it is. So this is pretty straightforward, okay? It told us immediately. I could not indicate the interrupt was raised because the transfer command was written or sent to a memory address out of range. Due to a malformed transfer command, the interrupt was not enabled. Therefore, it was not listened to. This case is shows how convenient and time-saving is the WinDriver debugger. The self-explanatory log could save us a lot of time trying to understand exactly what happened and where the issue relies, and why we could not see the raised interrupt. Okay, this example comes from Windows. A client reached us and said, I cannot, I'm getting a hang. I'm getting a crash. My computer crashes when I start to perform a DMA. So we say that if you want to to perform DMA, we need to make sure that the PC is compatible. Maybe there is an issue with an OS. Maybe there's a problem with the INF, not enabling, not allowing the DMA, and maybe the issue relies with WinDriver. Maybe the DMA mechanism is not working properly. So we asked for the WinDBG log and saw the trace stack, okay? And we see it's not saying a lot, but we can't see WinDriver here. We can't see the name WinDriver or a WinDriver function that ran before the crash. So here we said, okay, this is not something that is related to WinDriver. Not a WinDriver operation caused the crash. We looked at the INF and it looked okay. And then we opened the Minidump and we saw this error. The PNP detected fatal error, and we started investigating it on Google, right? On Windows documentation. In this, after a short investigation, it didn't take too long. We realized that there is something that is called policy CSP, DMA guard, okay? And you essentially cannot perform DMA because of DMA kernel protection, kernel DMA protection. Once it is enabled, everything that will try to perform DMA on your computer will result in a crash. This is a protection measure, right, of Windows on its users. It doesn't want anything to, imagine how catastrophic can it be. If anyone could just start performing DMA on the computer, on the hardware, on the devices. So it is enabled by default. You need to disable it in order to perform DMA on your computer. So this is just another case where, you know, a crash can say a lot of things, and you may think that something is broken with the card, maybe something in the code isn't right, you're writing to the wrong place. In this case, we found it using the Windows kernel debugger, the WinDBG, and documentation. After the client turned off the kernel DMA protection, we saw he was able to perform the DMA with no further issues. So let's talk about WinDriver mechanism and utilities. I will overview it like very quickly because I talked about it in different webinars, and if you're familiar with it, I don't want to waste your time. If you're not familiar with it, check out previous webinars, check out the video that we will upload tomorrow or at the beginning of next week about INFs, or go to our documentation. Basically, this is the user mode we are developing here, and this is the kernel mode, where the hardware access takes place. The whole point of WinDriver is to make the development of the driver much easier. Only from the user mode, we're using an API. We have the high-level API and low-level API communicating with the kernel module. On Windows, we need to have INFs to enable the access to the device. We need to have a kernel module also on Linux. What happens if the kernel module is not loaded? I will get to that. We will see by the end of the webinar. But this is basically the structure, the mechanism of how WinDriver works. High-level API calling low-level API, making the development and debugging much, much easier. And another thing we have is the digital signature. I won't talk about it too long, again, because there's a lot of info out there. But basically, Windows will not let you install unsigned INF. What do I mean by unsigned? INF that weren't digitally signed by Microsoft. We offer this service, okay? You can purchase the digital signature service with attestation signature. We are Microsoft partners. So if you develop the driver using WinDriver, and this is important, only drivers that were developed using WinDriver due to security issues, of course, we will be able to sign on your driver. One thing we've added in the recent version is the self-signed certificate. Okay, the cert-lem is another tool to see which certificates the operating system have. This Windows version have. You can install it with WinDriver installations, and then avoid rebooting the computer and disabling the digital signature enforcement each time, making the testing a lot easier. So what happens if the kernel module is not loaded? Okay, so as we saw here, in Windows, we need to have the driver INF, which by default is the WinDR VR driver, and we have the device INF, which is generated on the wizard for each device and each project. If the kernel module is not loaded, then we have the WDReg frontend, which is basically a kernel module loader on Windows. It looks like that. You can install and uninstall drivers, start them, stop them, create registry entry, or delete them. And on the new version, you can also create a test certificate and reboot the computer. If you don't want to use the friendly GUI, the front end, you can also use the CLI. And you can read more about it on chapter 16 on our documentation. This is an example of an error that takes place when WinDriver, the driver wizard, is we're trying to run the wizard and it's not working, and then we get this error, and it says make sure the WinDriver kernel module is installed and enable it on the device manager. So if we get this error, either if running WinDriver or our driver, what we recommend to do is open the setup API devlog. And as I said, warnings are with 1 exclamation point and 3 marks, and 3 exclamation marks indicates an error. And it says exactly what is the issue and what went wrong with each INF. So we look for the error in the setup API devlog. In this case, we ask the client to remove previous WinDriver versions that interfered with this driver wizard runtime. As I said, we have on our documentation the instructions for how to upgrade the WinDriver version. Removed related INFs and sysfile, either with PNP util, we talked about it, in devices from the class Django, and delete the drivers that can interfere with the runtime of the WinDriver. Then asking to reinstall WinDriver on a clean computer and enabling the driver on the device manager. On Linux, it is simpler, okay, much simpler. We have the ls mode command in order to check if the kernel module is loaded, WinDriver kernel module. If you will try to run your driver or WinDriver, you will get this error. You fail to initialize the WDC library, invalid handle. Or you will see the error we saw here, just on Linux. In this case, we will recommend to load the kernel module using the wdrag utility. Very, very easy. And if you are not using, you are not trying to run WinDriver, but your generated project, you would need to rename the driver to change it on the lib.c file of your project. If you don't know how to do it or encountered issues, go to our documentation or reach out. Other great utilities we have to check if our hardware works or our operating system can access it and perform operations is the PCI diag and USB diag. Diag stands for diagnostic, okay? You can review the resources of connected USB or PCI devices and communicate with them to transfer data from to the device, to read and see the config bar information. It is located on the util folder of WinDriver. You can simply double-click it and just access your device. If it has an installed INF, you can scan the devices, allocate or free shared buffer for DMA, for example, and essentially do many things with your device, write to specific offsets and access registers. What is it good for? Why is it a good troubleshooting tools? Because if you, let's say, unable to access your device from your project, okay, from a code you written that generated by WinDriver, and you integrated the code to your driver or wrote your code inside the generated code, and if you encounter issues opening the device, accessing it, you have this tool. It is a working application with a built-in interrupt handler, so you can perform the operations there. And if it is working on the PCI diag or USB diag, then something is probably wrong with the driver you created. If it's not working here, then it is worth checking the operating system. Because as far as we can tell, this application should work and access your device with no further issues. So it's a great debugging tool, and you can also track it down with the WD debug with the default kernel module. So in this case, I wanted to show what happens if our driver wizard is not identifying our device. Okay, so we open the wizard and we started a new project, and then we need to select our device. We need to look for the device on the list, and if it's not there, then we need to look for it on the PNP util, on the device manager, or in PCI or USB, LSPCI or LSUSB on Linux. Now, if it is not there, then the operating system does not recognize the device. And then again, we need to check why. With either with the debugger of the operating system or moving the device to another PC and see if it works there. However, if you find the device on the operating system list, you can utilize the PCI or USB diag tool from the util folder of WinDriver and see if it appears there, if you can access it, and you can perform operations. Log everything with the WD debug GUI, or event viewer, or other relevant tools. And if you encounter more issues, then contact us. But again, it just shows how much can be done. Regardless of support and documentation and everything, we have a lot of tools to track down the different stages of the process and find the root cause. That's it. I want to thank everyone for joining, If you have questions, this is my email. Feel free to reach out, ask questions. And I hope to see you on the DMA webinar as well on the 22nd of May. It would be very, very interesting. Thanks and have a great day.